Welcome to Understand All. I'm your host, Aslakir Gerleaf. Today, we're embarking on a fascinating journey into the world of geoengineering, exploring the audacious idea of controlling the weather to save our planet. So buckle up, it's going to be a wild ride. Imagine a world where we could adjust Earth's thermostat, a world where we could brighten clouds, inject reflective particles into the atmosphere, and even install giant mirrors in space to reflect sunlight. Sound like science fiction? Well, it's not. It's geoengineering, and it's a hot topic in the fight against climate change. But what exactly is geoengineering? In a nutshell, it's the deliberate large-scale intervention in the Earth's climate system to counteract global warming. It's like giving the planet a giant aspirin to bring down its fever. The idea has been around for decades, but as climate change accelerates, geoengineering is gaining more attention as a potential Plan B. There are two main types of geoengineering: solar radiation management, or SRM, and carbon dioxide removal, or CDR. Think of SRM as adjusting Earth's thermostat by reflecting more sunlight back into space. CDR, on the other hand, is like cleaning the atmosphere by sucking out the excess carbon dioxide. Let's dive into SRM first. One popular idea is stratospheric aerosol injection. Essentially, we'd spray reflective particles, like sulfur dioxide, into the upper atmosphere to create a giant mirror. According to a study published in Nature Climate Change, this could potentially cool the planet by about vertigrade C if deployed at scale. That's a pretty significant temperature drop. But hold on, there's a catch. Messing with the atmosphere could have unintended consequences. A study in Nature Communications warned that SRM could disrupt weather patterns and impact agriculture. Imagine trying to adjust Earth's thermostat and accidentally turning off the rain in some regions. Oops! Another SRM technique is marine cloud brightening. The idea is to make clouds more reflective by spraying salt water into the air. Brighter clouds would reflect more sunlight, cooling the planet. But as research in atmospheric chemistry and physics points out, the effects are highly uncertain and could alter precipitation patterns. It's like giving the clouds a makeover without knowing if they'll cooperate. And then there's the sci-fi solution: space-based reflectors, giant mirrors in space, reflecting sunlight away from Earth. It sounds cool, but the feasibility and costs are astronomical. A study by the University of Strathclyde estimated that a fleet of space mirrors could cost up to $350 trillion. That's a lot of pocket change. Now, let's talk about CDR. One method is direct air capture, basically giant machines that suck CO2 out of the air like cosmic vacuum cleaners. The American Physical Society reported that current technology could capture CO2 at a cost of $600 per ton. That's a steep price for fresh air. Another CDR approach is enhanced weathering, which speeds up natural processes that absorb CO2. A study in Nature Communications estimated that if implemented globally, enhanced weathering could capture 2 to 4 gigatons of CO2 per year. That's like planting a forest the size of the United States. But perhaps the most controversial CDR method is ocean fertilization. The idea is to feed the ocean with iron to stimulate the growth of algae, which absorbs CO2. However, the Royal Society warned that this could sequester up to 3.7 gigatons of CO2 per year, but with significant ecological risks. It's like giving the ocean a multivitamin with unknown side effects. So, geoengineering could be a powerful tool in the fight against climate change. The Intergovernmental Panel on Climate Change suggests that CDR methods could potentially remove 100 to 1,000 gigatons of CO2 by 2100, depending on the method and scale of deployment. That's equivalent to reversing 2 to 20 years of global emissions. But with great power comes great responsibility. Geoengineering raises serious questions about international cooperation and decision-making. Who gets to control the global thermostat? What if countries disagree on the optimal temperature? A report by the National Research Council warns that unilateral geoengineering actions could lead to geopolitical tensions. It's like trying to agree on a thermostat setting with 195 housemates. And then there are the ethical concerns. Is it right for us to play God with the climate? Do we have the wisdom to manage the risks? The Convention on Biological Diversity has called for a moratorium on geoengineering activities that may affect biodiversity until there is an adequate scientific basis. It's a reminder that we're not just tinkering with a thermostat, but with the delicate balance of life on Earth. Despite the challenges, research into geoengineering continues. Scientists are conducting small-scale experiments and running computer simulations to better understand the potential impacts. Did you know that the Stratospheric Controlled Perturbation Experiment, or SCOPEX, plans to launch a balloon into the stratosphere to test the effects of aerosol injection? It's a small step towards understanding a giant leap for humanity. As we ponder the future of geoengineering, it's crucial to remember that it's not a silver bullet. It's a potential complement to, not a replacement for, emissions reduction and adaptation efforts. According to a report by the National Academy of Sciences, the economic impacts of geoengineering could be significant, both in terms of costs and potential benefits. But the most effective solution is still to cut greenhouse gas emissions and transition to clean energy. In the end, the question of whether to geoengineer or not is a deeply human one. It's about our relationship with nature, our responsibility to future generations, and our capacity for wisdom in the face of unprecedented challenges. As the science fiction author Kim Stanley Robinson put it, "We're in a science fiction novel now, and we have to be the authors of it as well as the characters." So, where do we go from here? Well, it's vital that we continue to research and debate geoengineering openly and transparently. We need to engage the public, policymakers, and stakeholders in a global conversation about the risks and benefits. And we need to do it soon, because the clock is ticking on climate change. But perhaps most importantly, we need to approach geoengineering with humility and caution. As the physicist Richard Feynman once said, "It is not our business to prescribe to nature. Our job is to understand her. We may have the power to control the weather, but we must wield that power with wisdom and restraint." And that's our exploration of geoengineering, the audacious idea of controlling the weather to save the planet. I hope you've enjoyed this journey into the uncharted territories of science and ethics. Remember, the future of our planet is in our hands. Let's make sure we're writing a science fiction novel we can all be proud of. Until next time, stay curious and keep exploring the wonders of the world around you. I'm Aslakir Gerleaf, and this has been Understand All. Thanks for listening.